Alright, chapter 4, section 1. We're going to graph sine and cosine. Most of you guys have probably already done this before, so hopefully it should be a review. I'm going to do this lecture in two parts here. First one, just going to kind of cover the basics of sine and cosine, and then start looking at shifting sine and cosine, changing the period, changing the amplitude, changing vertical shift, horizontal shift, those sort of things, and what they look like and how they can impact, from the parent function of sine or cosine. Okay, so first of all, let's just briefly cover what's a periodic function. Okay, it's a function that is repetitive over and over and over. So like we go around the sun every year. All right, that's a periodic function. We have our seasons. Okay, periodic function. We have high tide, low tide, those sort of things. Something that we consistently can count on. All right, your heartbeat when you're laying in a hospital bed is normally periodic, right? It's going to be different if you're running versus walking versus those sort of things. Okay, but what a periodic function is, okay, and when we interpret this algebraically, we have f of x equals f of x plus n times p. Okay, so for every real number in a domain, okay, we have an integer n that we in some positive p, where p is the period. Okay, that's the amount of time for that function to repeat itself. Okay, so that's very, very, very important. So, what we have here is we're going to take going around the unit circle, and we're going to be creating, our sine or our cosine graph and how that's developed. So that'll gain a very basic understanding for us, of where sine and cosine comes from. So right here, this is just a demonstration of, how we go around the unit circle and how it actually creates a periodic function. Whether we're creating sine or cosine. They're very similar waves, okay? It's just a matter of where they start based on the unit circle. Okay, so remember, periodic functions are repetitive every 2 pi for what we're going to be doing. Okay, the basic, that's the parent function for sine and cosine. That's the circumference of the circle, which is 2 pi. So one complete revolution around the circle is 1 period for us. In general, the parent function for sine and cosine, they're periodic functions with a period of 2 pi, which means they repeat themselves every 2 pi. So 0, 2 pi, 4 pi, 6 pi, 8 pi, 10 pi, 12 pi, and so on and so forth. They go on forever and ever and ever and ever. So we can represent them here as sine x equals sine of x plus n. That should be times. Somehow the multiplication sign got lost in translation here and became a block for this PowerPoint. So it should be sine of the quantity of x plus n times 2 pi. And cosine is going to be cosine of x equals cosine of the quantity of x plus n times 2 pi. Or n can be any integer, right? We can be 0, 1, 2, 3, 4, 5, 6, 7, 8, so on and so forth all the way up. And it holds true for every integer when we're taking a look at a periodic function. That's just a definition of a periodic function from a few slides ago. We're just throwing sine and cosine into the mix here. Alright, so we got a couple things to look at. So first of all, the graph is just a representation of us rotating counterclockwise around a circle and how we create a sine and a cosine function, where it comes from as we go around the circle. So looking at the colors, that will help us determine what graph we're looking at. The green represents, on the unit circle here, right, the vertical aspect of our right triangle. If we look back at our reference angles, that's the height. That's the height, that's the y aspect, that's the sine aspect. So the green on the unit circle corresponds to the green graph that's going along. That's the sine function. Then the other function, the purple looking color, that's sliding back and forth on the x-axis, that's the horizontal component of our unit circle, right, as we went around and did our special triangles, 30, 60, 90, 45, 45, 90. That's the horizontal piece. Remember, I told you to remember that horizontal goes with cosine. So what's the purple graph is a graph of the cosine function. And it really just repeats over and over and over. And it just depends on if we want a sine function or a cosine function. Sometimes we set it up that way because our electricity, when we're dealing with three-phase electricity, they're 120 degrees out of phase with one another. So, sine can look like cosine if it's shifted, because sine and cosine are only 90 degrees out of phase with each other. But now let's